Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I'm going to continue with your module that is procedural programming. In the yesterday's class we have finished with the 7th chapter, that is chapter number 7, that is the C preprocessor. In the today's class I'm going to start with your new topic, that is chapter number 8, arrays. Before that, let's take a quick review what we have covered in the last class. In the last class we have covered about the chapter number 7, that is a C preprocessor. C preprocessor means before processing what are the steps, that is a preprocessor, that is before processing what is the role, what is the task, that is the preprocessing. So these are the elements that we have discussed in the last class. First of all, we have discussed about the what is a preprocessor. So it is a program that processes a source program before it is passed to the compiler. So it is nothing but a program that processes our source program before it is passed to the compiler. Preprocessor commands, also known as the directive. We have discussed that this another name for the C preprocessor is known as the directives. Then we have discussed about the features of preprocessor, that is what are the features available for the preprocessing. Then we have discussed about the various features, like when we save or when we combine with the or when we use the preprocessor feature, what is the main advantage, why we are using them. So we would learn the following preprocessor directives, that is a macro expansion, file inclusion, and this is the basic structure that we have discussed. This is a place where preprocessor arrives, that is this is a place where preprocessor role comes in. First of all, there is a handwritten program, then there is a text editor, then there is a source code, that is a C source code, then there is a preprocessor, then there is a expanded source code. Means text editor converts the handwritten program into the source code, while the preprocessor converts the source code into the expanded source code. Then there is a compiler, then that compiler converts the object code or the source code into the object code, then that object code is converted into the executable code with the help of the linker. That is, linker is used to convert the object code into the executable code. Then this is a processor, this is the different types of processor, and what are the inputs and what are the outputs. So first of all, there is an editor. It takes the input as a handwritten program, generates the output as a C source code. The same task, it takes the input as a C source code, generate the expanded C source code, that is a source code file with the pre-processing commands. That's why it is known as the expanded source code. Then this is the compiler that takes the expanded source code and convert into the next source code. What we have discussed is the next processor is the linker, then the compiler. What is the input and what is the output? So this shows, or table shows how table will be, or how generator will be generated. All awesome. Now it's okay. Hello. Hi, listen. It's okay. Then we have discussed about the macro expansions. What is the macro expansion, how it will be used. Then we have discussed about this example. This is the example. This is the A preprocessor that is used, one preprocessor that is used is hash define upper 25. Then there is a main function. This is the example, this is the syntax, this is the code that is given for the main function. This is known as the macro definition. Means wherever the 25 is used in the program, wherever the upper is used in the program, that upper will be replaced by the 25, that is the 2525. Means whenever the upper or the upper function is used, that upper function is replaced, or the upper keyword is replaced by the value, that is a 25 value. This statement is known as the macro definition, or more commonly known as the macro. Then we have discussed about the different types of macro, what is the usage, or how we can define the macro, what is the main purpose of defining the macros. This is the hash define directive that is used many a times to define the operator that is used. That is, it is also used to define the operator. That is, we can define the AND operator with the symbol. So whenever we use the AND, this means the double ampersand. This is the symbol that is used. That's why we define the AND as a symbol. In the same way, we define the OR as a 2 pipes. This is the OR that is used to denote 2 pipes. This could be used to replace even an entire C program. That is, entire C statement, not program. This means this is also okay. Means whenever we type found, it will be used to print this line, print this statement. Right. Then we have discussed about the macro with arguments. That is how we can use the macro with the arguments, or how macros is used with the argument also. This is the example of argument also, that is parameters also used for the along with the macro. This is the area, that is a macro. These are the various argument that is used. This is the example of how using the main function. This is another example of macro with argument. This is the next example that is used. These are the points that we have discussed in the last class whenever we use the macro with the arguments. First point says, be careful not to leave a blank between the macro template and its argument. That is, don't leave any blank space. This is blank space instead of writing this one. That is, this is the wrong part whenever we use the blank space between the macro and the arguments. Then the entire macro expansion should be enclosed within the parenthesis. Then macro can be split into the multiple lines also by using the backslash. If for any reason you are unable to debug a macro, then you should view the expanded code of the program. Then we have discussed about the macro versus function. This is the most important part, that how macro or what is the main difference between the macro and the functions. The moral of the story that we have discussed is macro is sweet. Simple and sweet, like in our example. It makes night shortened and avoids the overhead associated with the function. That is, macro is so simple as comparison to the functions. Then we have discussed about the file inclusion, that how file will be included. That is how this will be used, like hash include file name. This is the second preprocessor directive that is used in this chapter, that is the file inclusion. That is how file will be included. That is hash include file name. And it simply causes the entire content of file name to be inserted into the source code at that point in the program. Of course, this presumes that the file being included is existing. That is, the file that is used is the existing file that is used whenever we include the file in the inclusion. When and why this feature is used? It is used in two cases. That is, hash include is used in two cases. If we can have if we have a large program. That is, if we have a large program, the code is divided into multiple files, each containing a set of related functions. Then the next category, that is the second part, how or why we can use it. It can be used in the cases, or what are the cases that is used. There are some functions and some macro definition that we need almost in all the program that we type. This is the next part that we have discussed. This is the next example. These commonly needed function and macro definition and can stored in a file. Actually, there are just two ways to include or to write hash include for statement. That is, there are two ways whenever we write or whenever we say that we are able to use the write function or hash include statement. That is, this is the way, or these are the two way how hash include will be used to include the file name. Then we have discussed about the conditional compilation, how conditional compilation is done. That is using the if-def, that is the if definition macro name. That is uses the conditional compilation, that is if defined, and end if, that is the end of the if. This is the if def. Then there is a one part, that is the undef, that is the if there is no defined, that is the undefined function. This is the example of the hash if and the else if. That is how if and the else if directive will be used. This is the example. Then we have discussed about the test statement, how if and the if else if will be used. This is the if, this is the else, this is the end if. This is the example that we have discussed. Then we will discuss about the miscellaneous directive that is used. Two directives are used as a miscellaneous. One is undefined, that is undef. One is the pragma, that is used to turn on and the off certain features. This is the warning that is used. Then we will discuss about the summary. That is what we have covered in this chapter. These are the various questions that is used or that is performed by the student. Then in the today's class I am going to start with the new topic, that is the next topic, that is the array, that is the chapter number 8. This is my first class, this is my today's session, this is my today's topic, that is chapter number 8, arrays, how arrays will be used. So let's start with the chapter number 8, that is the arrays. So what is an array? If I say, or if I am saying that it is a collection of homogeneous data type, means whenever we collect or whenever we combine the similar data type, like I am defining 5 variables and all the 5 variables are of integer type, then I say that it is an array of 5 integers. That is the same data type, the same variable name, but all the data type have the same, all the variable has the same data type. This is the best example. That is, if 5 variables are used, both have a data type int, then we can say that int 5, that is the 5 will be used as an, or 5 variable will be used as an integer. Then in other words, we can also say that array is a homogeneous collection of data type. That is, it is a homogeneous collection of data type. Then in this chapter there is a array initialization, how we can initialize the array, how we can check the bounds, that is the bound checking. Then pointers and array, that is how pointer will be used, 2-dimensional array, 3-dimensional array, and the array of a pointer. These are the topics that we have discussed. Believe me, this is one of the important topic that is discussed. That is discussed in the C language. This is the best and the important topic. So let's start with the array. This says the C language provides a capability that enables the user to design a set of similar data type. Design a set of means develop a group of similar data type. Like if I am using 5 integers, that is a similar data type, means all the 5 data type are of the similar, that is the int, known as the array. So that means it enables the user to design a set of similar data type that is known as the array. This chapter describes how array can be created and how it will be manipulated in the C language. So this is example. This is a array, that is, it is a collection of homogeneous data type, similar data type, that is known as the array. We should note that in many C books and course array and pointers are taught separately. I feel it is worthwhile to deal with these topics together. This is in most of the C books that is used, that is differentiate between the array and the pointer. But it's better to use, or it's better to study them all together. Why? Because they are related with each other. In fact, all the array make use of the pointer internally. Hence, it is too relevant to study them together rather than as isolated topics. So what are arrays? For understanding the array properly, let us take the example. In this, three variables are declared. Both are of integer type. One has a two variables are declared. Both has a integer type because int is given. One has a value 5, one has a value 10. Then print the value. No doubt this will print the value of x as a 10 because when a value 10 is assigned to the x, this will be override, or this 10 overrides the 5 value, because first of all the value is 5, but then sudden the 10 value is given to the x. That means 10 overrides the value of 5. This means because when a 10 is assigned to s, the earliest value is lost, that is the 5. Therefore, ordinary variable, that is the one which we have used so far, are capable of holding one value at a time. That is, the variable that we have discussed right now or till now, that holds only one value at a time, either 5, either 10, either 15. However, there are some scenarios, there are some situations in which we want to store more than one value at a time in a single variable. That is, it is a time, or it is used to store more than one value or more than one value at a time in the single variable. That is the array. For example, suppose we wish to arrange the percentage marks obtained by the 100 student in ascending order. That is, suppose my requirement is that I want to, or I wish to arrange the percentage marks by hundreds, or obtained by 100 student in ascending order. That is, we want to arrange the marks. In such a case, we have two options to store these marks in memory. What are the two options? Either I create 100 variables separately of integer type, 1, 2, 3, 4 till 100 variable, to store the percentage marks obtained by 100 different students. That is, each variable containing one student marks. Right. Another way is that construct only one variable known as the array or the subscripted variable that stores or holds all the 100 values. That is, either we use 100 variables, either we use one variable that stores 100 values. Obviously, the second alternative is better. Why? Because first alternative says that there are 100 variables, so I have to define the 100 variable, write the 100 variable. That is too lengthy process. So the second one is better, that is, define only one variable that stores 100 values. Obviously, the second alternative is better. A simple example for this is, it will be much easier to handle one variable than handling 100 different variables. Moreover, there are certain logic that cannot be dealt with without the use of an array. That is, there are certain scenarios, there are certain programs which cannot be dealt with, which we cannot use without using the arrays. So array is a collective name given to a group of similar quantities. This is the most important point. Similar quantity is one of the most important part. So array is nothing but a collection of a name that is given for a group of similar data type, similar quantity. That is, when we combine similar data type, that is known as the array. These similar quantities could be of percentage marks of 100 students, salaries of 300 employees, or age of 50 employees. So we can take any one, either percentage, either salary, either age of 50 employees. So what is important is that the quantities must be similar. That is, the quantity means the data type that is used is the similar one. Each member in the group is referred by the position in the group. That now this is the time that how each member of the array is used. That is, how each member is represented. Each member is represented by the location number. Location number means that the position in the group. Suppose, for example, assume that the following group of number which represent percentage marks obtained by the 5 students. That this is the percentage marks of the 5 students that can be represented, or that is represented by using the array. So percentage is the array that stores 5 values. One is 48, one is 88, one is 34, one is 23, one is 96. So these 5 values will be stored as an array. What is the array name? That is the percentage. Now, if you want to refer to the second number, the usual notation is per 2. Similarly, the fourth is per 4. But in C, the fourth is referred as a per 3. That is, it starts with the 0. It is 0 location, 1 location, 2 location, 3 location. So this fourth one is understandable, or this fourth position is known as the third position or the third location. Why? Because it starts from the 0. This is because in C the counting of elements begin with the 0, not with the 1. Therefore, in example, per 3 refers to the 23 and per 4 refers to the 96. In general, the notation will be per I, where I can take 0, 1, 2, 3, 4 depending on the position of the element being referred. If we are using 10 variable, then start with the 0 and ending with the 9. That is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Here per is the subscripted variable, that is per is the array variable where I is its subscript. So one is known as the subscripted variable or array, and the index and the value that is used, that for example I, this is the I, this I is known as the subscript. So this I is used to define the location in the array. Suppose per 0, that is the first location, first element, per 1, that is the second element, per 3, that is the third element, and so on till per 5. This is 0, this is 1, this is 2, this is 3, this is 4. Not 5, this is 4. This array is a collection of similar elements. So therefore array is nothing but a collection of similar elements, similar data types. Either that data type may be int, that may be float, that may be double. This similar may be int, may be float, may be char, etc. Usually the array of characters is known as the string. That is, whenever we combine the characters, different characters, that is known as the string, string. Whereas an array of int or float is simply known as the array. That is, whenever we combine the char, that is we combine or we use the char variable, that is known as the string. But when we use the int, when we use the float, that are simply known as the array. That is not known as the string, because collection of characters or the array of characters is known as string, but the array of int, array of float is simply known as the array. Remember that the elements of a given number of any given array must be of same type. That is, we cannot have an array of 10 numbers, of which 5 are int and 5 are float. That is, all the elements of the array must be a similar data type, must be of similar data type, not that 5 I am using of int, 5 I am using of float. No, that's not possible. So this is the simple example, that is a simple program that is using the arrays. That is how a simple program will be used, or how a simple program will be created using an array. That is the array basic example. Now let us try to write a program to find the average marks obtained by the class of 30 students in a test. That is, let us now try, or let us now take or to write a program to find the average marks obtained by a class of 30 students in a test. That is, finding the average. How average will be finding? How average will be calculated? By first of all calculating the total marks and then divided by the total numbers. That means first of all adding up all the values and divide by the total number that is available. Suppose 5 numbers are available, then adding up the 5 values and then divided by the 5. That is known as the average. So now let's start. First of all, main function will be used, then there is a curly braces. Then one average variable will be used. Then next variable that is used is the sum equals to 0. So one variable name is average, another variable that is used that defines or that is used to initialize with the 0. So one is avg and one is sum equals to 0. Then int I. Next variable that is used is int I. Then int marks 30. So one average sum, then I, then marks 30. That is, marks 30 means 30 is allotted to the marks. That is, this is the variable. This marks is the variable that contains the 30 values starting with 0 and ending with 29. So it contains the 30 values and the array name is marks, right? Then uses the for loop. It starts with the 0 and ending with the 29. Why? Because it contains 30 elements and it starts with 0, it's ending with 29. Because I told you array in C, array starts with the 0. This takes the loop from the 0 to the 29, and there is a I plus plus. So this is, remember, this is known as the initialization, this is known as the condition, this is known as the increment. So these are the three parts. One is the increment, initialization, one is the condition, that is the test condition, one is the increment. So this is the I plus plus is the increment. Then curly braces will be used, then printf enter the marks. That is, this will be printed as it is. That is how it will be printed. That is printf enter the marks. That is, it will take the marks one by one from 0, 1, 2, 3, 4 until 90. Then it stores the data in the array, in the memory. How it will be stored? This I will be used. First of all, it stores the data at the 0th location, that is the 0 location. Then it stores the data at the 2 location, 3 location, 4 location, 5, 6, 7, 8, 9, 10 till 29th location it will store the data. So first of all 0, 1, 2. First of all at the 0th location the data will be stored. Then at the first location data will be stored. Second location data will be stored. Till 29th location the data will be stored. That is from 0 to 29 it will store. And it contains total 30 elements. It will store the data in the array. Starting with 0, 30 elements. Now calculate the sum, that is adding up the values, that is summing up the value, that is read the data from the memory. This is again starting with 0 ending with 30, that is starting with 0 and that is less than or equals to 29 I plus plus. Then sum equals to sum plus marks I. Now first of all sum contains 0 value. So this is 0 plus marks I. At the 0th location, what's the input that is given by the user? For example, user has given 5, 10, 20, 25 and so on. So at the 0th location this is 5. Now this is the 5, this is 5 plus 0, this is a 0, that has the output 5. Right. Now sum has a value 5. Again sum will be used, that has a value 5 and this marks 0, that is a 10, for example 10. So 10 plus 5 is 15. This will go to the 15. Again 15 plus, let's example this has a value 15. 15 plus 15, 30. This is 30. Now this is 30 plus 20. Let's example this is 20. So this is 50. Then again sum is 50 because this contains 50. This is 50. This is, for example 25, 75. So on, so on, so on. It will calculate from 0 to 29. That is till 30 values. Then at last the sum will be used or sum will be generated. That sum is divided by 30 to get the average. So now this sum is divided by the 30 and that gives the average of the number, and then average will be printed. That is the AVG. This is the best example of calculating the average. This means the sum will be calculated. First of all the marks will be entered by the user and then sum will be calculated by using the arrays. This means whenever we use the array we have to use the looping, because without looping the array cannot be used. So this is array average sum by 30. That is, as I told you, whatever the addition of the values that be divided by the number, total number, and in this the total number is 30. So it divided by the 30. Then printf average marks equals to percentage d and average. Now the average will be, or average value will be printed. Now there is a lot of new material in this program. Let us take it apart slowly. That is, let us take one by one very slowly. First of all, array declaration. This is the array declaration, marks 30. To begin with, like other variable, an array need to be declared so that the compiler will know what kind of array and how large an array we want. That is, it is better to initialize, or it is mandatory to initialize the array, because it is also like a variable. So it is mandatory to initialize the variable or the array variable before it is going to work with, or we are going to work with. That is marks 30. In our program we have done this with the statement. This is a statement that is used for initializing the array. This says here int specifies the type of the variable just as it is does with the ordinary variable, and the word marks specifies the name of the variable. This is the data type and this is the name of the array. The 30 however is new. 30 tells, or the number 30 tells how many elements of type int will be in an array. That is, this tells how many elements will be stored in the array or in the memory. This number is often known as the dimensions of the array. This is the most important. That 30 or 10, 20, any array elements are known as the dimensions of the array. This is the bracket that tells the compiler that we are dealing with the array. So arrays are always denoted by this brackets, and this is the value that is given in the array. That is known as the dimension of the array. Then next part is how to access the elements of an array. That is, how to fetch the elements. That is, for example, if I have to use only one variable, if I have to use two variables, three variables, suppose 5 variable will be stored in an average in an array. So how to fetch the second one, that is from whatever is stored in the third location, how we can fetch the third location, how we can get at what is stored in the third location. That can be used, or that can be fetched by using the array. How third location will be fetched? By using the second dimension, by using the second subscript. Why? Because I told you that it starts with the 0. So at the third location, whatever is stored, it will be fetched by the 0, or it will be fetched by the 2 subscript, that is the numeric 2. This says, once an array is declared, let us see how individual elements in the array can be referred. That is, once an array is declared, how it will be used. This is done by using the subscript. That is, or this is used means accessing the elements is used by using the subscript. That is the number in the bracket following the array name. This is marks2. That is, the marks is an array, and second is the location. So this will be located not the second one but the third one. This number specifies the element position in the array. That is, what is the position, or what is the element position that is defined in the array. Then all the array elements are numbers starting with the 0. That is, all the elements number, array element number means, as I told you, the array starts with the 0. Therefore marks2, this is the 2. That does not denote the second location. No, it denotes the third location. Why? Because it starts with the 0 and ending with the number that is given. So in our program, we are using the I as a subscript to refer to various elements of the array. This variable can take different values and hence can refer to the different elements in the array in turn. That is, the array variable can take any number of value, different value, and refer as the different elements in the array. This ability to use variable as subscript is what makes array so useful. That is, this is the advantage, or this is the main method how array will be used, and why array is very useful, or array is so useful. Then how to enter data into an array. That is, how to use the array, or how to feed the data into the array. That is, how to enter the data into an array. Here is a section of code that places the data into an array. So this is the way how we can enter the data by using the for loop. By using any loop means we have to circulate from 0 to 29. So either use while loop, either use for loop. But it is very beneficial if I use the for loop, because at the same line, it is declaring that is initialize the value, check the condition, and either increment or decrements the value. So it is the way, or it is the done in the various steps. So it is better to use the looping in entering the data into an array. So this is the example. It starts with 0, it ending with 29, and then printf enter the marks. That is, marks will be entered. That is, the printf enter the marks, and then this marks will be stored or enter into an array by using one by one. That is, first of all, it is stored at the 0 location, then it will be incremented, that is first location, then it will be incremented second location, then it will be incremented third location, then it will be incremented fourth location, then it will be incremented fifth location, and so on till 29th location it will be stored. The for loop causes the process of asking for and receiving a student mark from the user to the repeated 30 times. That is, it is used as a repetition of the 30 times. That is, first of all 0, then 1, then 2, then 3, 4, 5, 6 till 29. That is, it is repeated for the 30 times. The first time through the loop, I has a value 0. So the scanf function will cause the value type to be stored in the element, that is a marks 0. So first of all, it has a value 0, that is, it is stored at the location 0. That is the first element of the array. Then the process will be repeated until I becomes 29. This is the last time through the loop, which is a good thing because there is no array element like marks 30. That is, there is no element like this one. Why? Because it is start with 0 and ending with 29. This is the 31st location, 31st position, but there is no 31st position, so it stop at the marks 29. Then in scanf function we have used the address of operator. Why we are used the address of? Because we have focused, or we have used the variable. In doing so, we are passing the address of the array element to the scanf. That is, we are using this because we are passing the address. We have to store the data rather than value. So this says we are passing the address of the particular array element to the scanf function rather than its value, which is what scanf requires. Then how to read the data from the array? That is, how to read the data from the array. That is, the balance of the program reads the data block out of the array and uses it to calculate the array. The for loop is much the same. So this is the way how to read the data. This is the way how to read the data. The same way as we done the for loop is much the same, but now the body of the loop causes each student marks to be added to a running total stored in the variable known as the sum. So this sum will be used to store the data. When all the marks have been added up, the result is divided by 30. That is, when all the marks have been added up, all the marks have been combined, that will be divided by the 30 to get the average of the 30 students, of the total number of 30 students. So this is the way how to read the data, and this is the way how to calculate the average, and then this average will be printed. That is, printf average marks equals to percentage the avg. To fix our ideas, let us revise whatever we have learnt about arrays. So whatever we have learnt about the arrays, now quickly sum up into the different points so that these points will be clubbed up together and this point will be very useful. So the first point says an array is a collection of similar elements. So whenever we combine the similar elements like all int, all float, all char, so that is known as the array. So it is a collection of similar elements. Then next point says the first element in the array is numbered at the 0. So the last element is 1 less than the size of the array. So if first one is 0, so obvious the last one is the number of 1, or the 1 less than the size of the array. Next point says an array is also known as subscripted variable. If I am using marks as an array, that is known as the subscripted variable. Before using an array, its type and dimension must be declared. That is, before declaring or before using any array, it must be declared in the top. For example, marks 30, that is a type and the dimension. Type means it is of int, float, double, that is a type, and the dimension means the value or the subscript what is it given in the square bracket, like this one. Then however, big an array and its element are always stored in the contiguous memory location. This is very common point which we will discuss in the more detail later on. That is, however big an array, its element are always displayed in the contiguous memory location. Now more on the arrays, that is how array will be used. This says array is a very popular data type with the C programmers. That is how array will be used, and this is the very popular data type that is used with the C programmers. This is because of the convenience with which array lend themselves to the programming. That is, it is a very popular data type that is used that is used to lend themselves to the programming. The features which makes arrays so convenient to program will be discussed below, along with the possible pitfalls that is used in using them. So first one is array initialization. This is, so far we have discussed array that did not have any values in them to begin with. We managed to store values in them during the program execution. Let us now see how to initialize an array while declaring it. That is, how array will be initialized at the time of declaration. That is int num6, that is the array initialization, but it will be also, this is the array declaration, but this also initialized with the values at the same time when it is declared. That is, at this time it is also used as the array initialization. So this is num6, then 6 values are given, that is 2, 4, 12, 5, 45, 5. So 2 values are given, that is used. So this contains the 6 values that start with the 0 and ending with the 5. That is, first of all it will be stored at the 0 location, then first, then second, then third, then fourth, then fifth. So it starts with the 0 and ending with the 5. So there are total 6 elements that is stored in the num array. Then int n, this n is an array, this is of n number of values, means we can store n number of values in this. There is no limitation that we have to store only 6 values. This is unlimited array. Then this array is of float type. In this all the elements are of integer type, but this, the press array, is of float type, n number of elements, and this will be used as a float type, like 12.3, 34.2, 23.4, 11.3. That may be positive, that may be negative. So these are the 3 examples. One example says we have limit the size, that is the num6. Next example says there is no limit, there is no boundation on the size. Next point says the array that is of float type, not the integer type. This is says note that the following points carefully. Till the array elements are not given any specific value, they are supposed to contain the garbage value. That is, if in the second point there is no value that is given, that is n, there is n number of values. In this case, there may be a situation that this array also contains some garbage value, that is a wastage value that is also taken by the int n, that is the n array. Then next point says if the array is initialized where it is declared, that is, if it is initialized when it is declared, mentioning the if the array is initialized when it is declared, mentioning the dimension of the array is optional, that like in second example. So this is not mandatory that we have given the subscript, we have given the dimension. There is no boundation. Then array elements in the memory. Consider the following expression. What happens in memory when we take this declaration? This says 16 byte get immediately reserved in memory. Why? Because int takes 2 bytes and this array contains 8 elements starting from 0 ending with 7. So it gets the space, that is the 16 byte get immediately reserved in the memory. That is 2 bytes for the 8 integers. So there are 8 integers that take 2 bytes. So this 2 bytes will be stored, or 16 byte will be stored for the 8 integers. But if there is a window Linux system that occupies 32 bits, why? Because each occupy 4 bytes. That is, the int takes 4 bytes in the Windows or the Linux operating system. And since the array is not been initialized, all the values present in it will be a garbage value. That is, if we have not defined any value, this is, we have not defined the value, they contains the garbage value. At the first time they contain garbage value, but later on if I store some values, that garbage value will be reversed, or that garbage value will be replaced by our value that we have given into the array. What happens in memory when we make this dimension, as I told you, and since the array is not been initialized, all 8 values present in it would be a garbage value. This so happens because the storage class of the memory is assumed to be auto. As I told you about the storage class, so in this case the storage class will be assumed as a 0. That's why it is stored, or it will be stored the garbage value in it. If the storage class is declared as static, then all the array elements would have an default initial value as a 0. That is, if we use the static storage class, that is, it is a static storage class, then it will be initialized as a default initial value as a 0. Whatever be the initial value, all the array elements would always be present in the contiguous memory location. What do you mean by contiguous memory location? That is one after the another. That is, whatever the type, whatever the material it is used, it has a default initial value as a 0, and array elements are present or always present in a contiguous memory location. Either it takes the int, either it takes the float, either it takes a garbage value, either it takes 0. But the main concern is that it is in the it is available in the contiguous memory location. This arrangement of array element is shown in this one. This is the 12, this is the 34, 66, minus 45, 23. This is of integer array type because all the elements are integer. Whether they may be positive integer or negative integer, but all the elements are of integer type. And this is the memory address. This is 65508 10 12 14 16 18. Why they are the two difference? Because these are of integer types. That's why 8, 10, 12, 14, 16, 18, 20, 22. Now, bound checking. In C, there is no check to see if the subscript used for an array exceeds the number of array. That is, there is no standard way, there is no way to check that if I'm using 30 and I'm going to use the 35 element, there is no way to check the check the way how it will be exceed the size of the array. Data entered with the subscript exceeding the array size will simply be placed in the memory outside the array, probably on the top of other data or on the program itself. This will lead to unpredictable result. That is, if I'm going to exceed the value or the size of the array, that will give the unpredictable result, to say the least, and there will be no error message to warn you that you are going beyond the array size. In some cases, the computer may have just hang up. That is, the computer may hang up, but there is no warning that is given that you are exceeding the value. Only the computer will hang up. Therefore, the following program may turn out to be suicidal. This is the array element, the main function. This is the array that is declared. Num is the array, and that is of integer type. That stores only 40 value. That starts with 0, ending with the 39. That is 40 values. Then there is a I variable is used. Now, using the for loop, starting with initialization, that is 0, ending with 99 or 100, because it starts with 0 and going to the 100. Then I plus plus. Then num I equals to I. That is, at the 0th location it will be used, at the first it will be used, at the second it will be used, third, fourth, fifth, sixth, seventh, eighth it will be used. Then num 40. It is the 40 variable that is the array is a 40 variable, that is, it starts with the 0 ending with 39. So how we get the 30th location? No, it's not possible. How is that possible? Because that contain only 40 variable, that is 0 to 39. This is to see we do not reach beyond the array size. Is entirely the programmer botheration and not the compiler. Next, how to pass the array element to a function. Till now we have discussed about the simple array. Now next concept is how to pass the array element to a functions. But before this, let's take a break and then come back starting with this topic, that is how to pass the array element to a functions. So let's take 5 to 10 minutes break and then come back starting with this topic. So let's take a break. Now let's start with the next topic, that is how to pass the array elements to a function. So come back from the break. Let's start with the topic. This topic includes how array elements should be passed, that is whenever we call any function, how that function or that in that function we call the or we pass not the simple values, but we can pass the array elements with the reference. We can pass the array elements from one location to another location whenever we call the function. So this says array element can be passed to a function. That is, this is also a provision that array element can be passed to a function by calling the function by value or by reference. That is, we can use any method in the function. Either we can pass the value array elements by a value, either we can pass the array element by as a function or by the reference. That is, we can use call by value or we can use call by reference. In the call by value, we pass the values of array elements to a function, whereas in the call by reference we pass the address of array elements to a function. That is the same way, that is either pass the array elements or values of the array elements, or either use the address of the array elements to the function. These two calls are illustrated below. These are the two calls that is used, that is a demonstration of call by value. This is the main function, then int I, int marks. So this is the I will be used as an initialization, that is int I. Then marks is used as an array variable or the array variable that contains n number of values. These are the 6 values that will be initialized at this location, not 7 values, right? 55, 65, 75, 56, 78, 79, 80. Now it uses the for loop starting with 0 ending with 6. That is, it starts with the 0 and ends with the 6. That is, it starts with the 0 location, 1 location, 2 location, 3 location, 4th location, 5th location, 6th location. That is, it fetches the value from the 0 to the 7. Why 7? Because it starts with the 0 and ending with the 6. So as per this example, this is the 0, this will be stored at the 0 location, 1 location, 2 location, 3, 4, 5, 6. Although there are 7 elements, but these are referred by the 0 to the 6, because in array the processing or the numbering will start at the 0, that is from the 0 to the 6. This is I equals to 0, I is less than equals to x, I plus plus. I is less than equals to x means this will be as equals to the 6 or less than 6. Then display marks I. That is, first of all 0 will be used. That is, the 0 will be used, the output will be display, or the element will be display, or the call by value will be used. That is, this is the function. Display is the function that passes the array element as a value. That is, if remember when I told you about the functions, there are two parts. One is actual argument, one is formal argument. So in this situation, the actual arguments is although nothing but nothing the value, but it's an array element. So this is the line that shows how array element will be passed by using the function. That is, it is also a provision. We can pass the function, we can pass the argument, we can pass the array element with the function. This is the function, this is the array element that can be passed. So this is the actual argument. Then curly braces will be closed. Then next point says, or the next line is the definition of this display function. So this is the definition. Here the marks I will be given, that is one by one the marks will be given. That is, first of all at the 0th location the marks will be given, then 2 location, 3 location, 4th location, 5th location, 6th location. So starting from 0 ending with 6, it will be stored by using the display function. Then this is the definition of the display function. That is, this is the display. Then there is a int m, that is a new variable that is declared, and then prints the value of m. This is the output that is given. That is, first of all the 55 will be stored, that is display. That means this is the 55, then 65, this is the 65, 75, 75, 56, and so on till 90. So this is the case. This is used to store the data, that is used to store the array elements. Then this function, or this is the definition of the function, that is display int m printf. That is the one by one the value is given, and that will be printed by using the printf. Here we are passing an individual array element at the time of function display and getting it printed in the function display. Note that since at a time only one element is being passed, this element is collected in an ordinary integer variable, that is m, in the function display. That is, it will be used as an ordinary variable, that is m will be used as an ordinary variable that will be used along with the display. Now comes with the call by reference. That is the next part that is used, or how we can get, or how we can store the value, or how we can pass the array element by using the address, or along with the address. That is passing the array elements or passing the argument as an reference. That is a call by reference that is in use in function. First of all, the main function will be used, then int I. That means starting with the main function, I is a variable that is declared as of integer type. Then int marks, that is marks is the array variable, the same, this is the array variable, again same, the for loop will be used. Now the function name is different. There the function name is display, full display name, that is display, but here the function name is disp. Then there is the ampersand marks I. This is the ampersand. Why this ampersand is used? Because we are passing the reference, we are passing the address, not the value. That's why this ampersand will be used. Then marks I. Why marks I? Because it starts with a 0 ending with the 6. So there are total 7 elements that is used. So at the first location the address of 5th will be stored. Address of the 55 will be stored. That is at the first location, because the address will be passed. Then 65, then 75, 56, 78, 78, 90. So it stores the address, it passes the address, not the values. And in this is the definition of the function disp. Now this takes the pointer. This is the ampersand, that is the address. Here the pointer will be used, that is the pointer n. Now prints the value of pointer n. As I told you, whenever the asterisk and whenever the address of operator will be used. This is the value at address operator and the address of operator. When these two operators are combined with each other, they clash with each other and they only give the values. So this is how this ampersand is used over here. So this is n, this is ampersand. This ampersand and this asterisk will be clashed with each other, and the output will arrive that's stored in the n, and this is the output. This says here we are passing the addresses of individual array element to the function display. That is, we are passing the addresses of the element to the function display, that is the disp. Hence the variable in which this address is collected, that is the variable that is used, that is in this address, in this variable the address is collected, that is n is declared as a pointer variable. So this is known as the pointer variable. And since n contains the address of array element, to print out the array element, we are using the address of operator. As I told you, since n contains the address, so print the array element. So print the values of the array element, we are using the value at address operator, that is a asterisk operator. This is, read the following program carefully. The purpose of the function display is just to display the array elements on the screen. This program is only partly complete. You are required to write the function show on your own. Try your hand at it. That is, this is the function, or this is the main target, that why we are using the disp to display the array elements. The program is only partly complete. This is the main function that is used. Then there is a curly brace open. Then int I, that is the I will be used as an integer. Then marks, this is an array of variable that is used. There is an average that is contains unlimited number of values. So this contains 7 values. Then for I equals to 0, that is start with 0 and ending with 6. So it can store 7 values that start with 0 and ending with 6, and there is a I++. Now this is used to call the function that contains the array. So in this the reference will be passed, that is the reference will be passed from the function to the definition. This is the argument, this is the actual argument that contains the address operator. Now this is this one, and then show ampersand n. That is, now in display definition new function will be added, that is a show function. Now give the definition of the show function, and once the definition of a show function returns the output, that will be returning over here, and then this output will be returned over here. So this goes from the bottom to the top. Now next concept is pointers and array. That is how pointer and array are combined with each other and are used with each other. That is the pointers and the array. This says to be able to see what pointer have got to do with array, let us learn about some pointer arithmetic. We have learned about the pointer in the last chapter or the last to last chapters, but we did not have done the pointer arithmetic, that is the operations on the pointer. Arithmetic means plus, minus, divide, multiply. We have not go through that pointer arithmetic. So first of all, let's go through with the pointer arithmetic. So first of all, there is the main function that is used. This contains the variable the I equals to 3, that is I is a variable that contains 3 values, then pointer x. Then float j equals to 1.5 pointer y. Then char k equals to c pointer j. That is, one is variable is used of integer type, another variable is of integer type but a pointer variable. Next float j, that is of float type that contain 1.5, y is of float type, that is a pointer type. Then char k, in the same way the pointer will be used, pointer variable, that is a char pointer j. Then prints the value of I, j, k. Only print the value of 3, 1.5 and c. Now stores the address of I into the x. That is, x is a pointer variable, as I told you, that store, or it is a pointer variable that stores the address of another variable. So this x will be used to store the address of I. Then y will be used to store the address of j. Then z will be used to store the address of k. Now addresses will be stored. Now the original address is x, y, j, right? So till now we have printed the values of I, j, k, and then we have printed we have stored the addresses into x, y, z, and then prints the address in the form of x, y, z as the name original address. Then x plus plus, y plus plus, z plus plus. Then the addresses, because the x contains the address, now addresses will be incremented one by one. First of all, x address will be incremented, then y, then z. So these three addresses will be incremented. Then printf new address in n, that is the new address is given or the new address is after incremented. So whenever the address is incremented, if it is of integer, it will be incremented by the 2 bytes. If it is float, it will be incremented by 4 bytes. If it will be char, it will be incremented by only 1 byte. So this is the output. First of all, the value will be given 3, 1.5 and c. Now this is the original address, that is 655242019. This is the example that is taken. Now this first x is of integer type, so this will become 65526. Before 24, now 26. Then it is of float type, this will also incremented by 4, so this becomes 65524. Then this is 65519, that will be incremented, that becomes 65520, because char takes only 1 byte. So this is the way how we can, this is the example that shows that how addresses will be incremented. This is this is the explanation of the same what we have said. This since z points to one location after the current location, this is very important result, and so on. The way a pointer can be incremented, it can also be decremented as well to point to the earlier location. Therefore, the following operation can be performed on a pointer. So we can also perform the operations like addition, subtraction, division, multiplication. That is, we can divide the values from the address, we can divide the address, we can add the number, we can subtract the number from the pointers. This is the example. First of all, I is equal to 4, pointer j, pointer k. Now j contains, or j pointer contains the or stores the address of I, that is the 4 address will be stored in the j. Then j equals to j plus 1, j equals to j plus 9. That is 1 will be added to the j variable, 9 will be added to the j variable, 3 will be added to the j variable that will be stored in the k. So k is the variable that is stored or by incremented after 3. That is the 3 will be incremented to the j and that will be stored in the k. This is the subtraction. That is how subtraction is done by using the variable. And this is a subtraction from the pointer. This is the example like j equals to j minus 2, j equals to j minus 5, k equals to j minus 6. In the same way, we can also subtract the variable or from one pointer to the another pointer. Now, this is the way how subtraction will be done. Now sound is audible, so I'm repeating again. Okay, this is the subtraction of one pointer from the another. That is this is also a method, or this is also a way we can subtract the one pointer from the another pointer. In the same way we perform the addition, in the same way we perform the subtraction. So this says one pointer variable can be subtracted from another provided both variable points to the element of the same array. The resulting value indicates the number of bytes separating from the corresponding array element. This is the example. In this, the array will be declared. This is the these are the elements of the array, and then after declaring the arrays, the pointer will be used. Then after declaring the pointers, the I will be used to store the address of 1. The j will be used to store the address of 5. Now, suppose the address the array begins at the location 65502. Then the elements array 1 and the array 5 will be present at the location 65504 and 65512. Why? Because this contains only one element. So this will be incremented by only 2 bytes. This contains 5 elements. So these 5 elements are multiplied by 2. So it will be incremented by the 10 bytes. So this is 65504. This will be incremented by 04. This will be 65502. This will be incremented by 10 bytes. That becomes 65512. In the same way, we can also perform the subtraction like j minus 1, because j and I are the pointer variables. Then next arithmetic of the pointer is comparison. We can also compare the two pointer variable, that is comparison of two pointer variables. This is the example. This is a program that shows how comparison is done between two pointer variables. This is the array that is declared. These are the 7 elements that is declared in the array that start with the 0 and ending with the 6. So at this 10 will be placed at the 6th location, 20 will be placed at the 7th location, and there are two pointers that is used, that is pointer j and the pointer k. J will be used to store the address of the array element that is at the 4th location. This is the array element that is used to store the at the 4th location. This is at the 4th location, that is 72. Now k is also a pointer that stores the address by incrementing the 4. That is, first of all the array will be incremented by 4, then output will be stored in the k. Now compares the j and the k. So these are the two pointer variable j and k. Now comparison is done between the j and k pointer variable. If j equals to k, so this is the comparison operator that is used, that is a double equals to. If both are the equal, printf, that is display that the two pointers point to the same location. Otherwise, that is else part, printf the two pointers do not point to the same location. So this is the comparison how, or this is the way how comparison is performed between two pointers. One more thing, this is the important thing, that the addition of two pointers would never work, multiplication never work, division of a pointer with the constant never work. That is, we cannot add two pointers We cannot multiply a pointer with the constant variable. We cannot divide of a pointer with the constant. So these are the three rules, that we cannot perform the addition of two pointers, we cannot multiply the pointer with the constant, we cannot divide the pointer with the constant. So these are the three important things that you should know. Now we will try to correlate the following two facts which have been learnt above. That is, we have learned the facts what we have learned. Let's combine with this. First point says array elements are always stored in contiguous memory location. That is, the array element that is stored in the contiguous memory location, that is one after the another. A pointer when incremented always point to an immediately next location. That is, whenever we increment the pointer, that always points to the immediately next location of the type. Suppose we have an array num. These are the elements. The following figure shows this array is located in memory. That is how elements are stored in the memory. That is the main part. So this is the example. This is the location, that is 65514121416182022. Then these are the value that is stored in that location. First of all, 24, 34, 12, 44, 56, 17. This says here is a program that print out the memory location in which the elements of this array are stored. This is the example. First of all, main function will be used. Then int num, that is, the num is the array variable that stores the value. These are the value that is stored. Then there is a I variable. Now uses the I variable with the for loop, that is for I equals to 0, I is less than equals to 5. So it starts with the 0 ending with the 6. That's why it captures 6 values. Why? Because at the 0 location this 24 will be stored, at the 1 location 34 will be stored, at the 2, 12, 44, 56, 17. So it starts with the 0 ending with the 6 to get the 6th value. Now uses the loop, that is I equals to 0, I less than 5 equals to 5, I plus plus. Then printf element number. So this printf or prints the element number, that is the I. In the same way it prints the address, that is the num I. So first of all it prints the element number 0, 1, 2, 3, 4. Then at the 0th location the what will be value, that is the num I. In the same way num1, in the same way num2, in the same way num3, and the 4 and the 5. So first of all this inner loop will be terminated, then only the outer loop will execute. This is the for loop, that is the inner loop. There are two printf statements that is given in the for loop. This is the output. For example, the element number. First of all there is a 0, the address is 65512. This is the example. Then element 1. This is the element 1. Then the value will be 34. The address will be 65514. Why there is a difference of 2 to each? Because it is of integer type. In the same way element 2 address is this one, element 3. The main role is that how we can print the element number as well as the address. Suppose I want to display in another line address, then always use the percentage /n over here. If I want to, that address will be printed in the next line after the element number. Now this is the element number, that is 0, that has the address this one, element number 1 that has the address this one, 2 that has the address this one, till address element number 5. That is from 0 to 5 it has a different element and it has a different addresses. Notice that the array elements are stored in the memory locations, each element occupying 2 bytes each. Why it takes 2 bytes? Because int takes 2 bytes since it is an integer array. When you run this program you may get different addresses, but what is certain, it will get of 2 bytes. Our next two programs shows in which we can access the elements of the array. These are the two programs that you have studied by your own, and if there is any doubt then please ask from me. Next method is that which accesses the array element using the pointers. This is, in this there is no pointer is used, in this the pointer is used. So this is the next example that includes the pointer variable. The I is a simple variable and j is a pointer variable that stores the address of the num, that is the array variable. This is the for loop that is used, that is I equals to 0, I is less than equals to 5, I plus plus, that is start with 0 ending with the 5, that is from 0 to 6 it will be stored. First of all the address will be printed, then element number will be printed, then j plus plus plus, that is the this pointer j that stores the address, this will be incremented one by one. That is first of all the different address, then incremented by 2 bytes, then incremented by 2 bytes until at last the loop will never terminate. In this program the basic concept is given that these two programs you have to study, because everything is not depend on the instructor, not depends on the faculty. So please study these two programs, and if there is any doubt then please ask from me. The explanation is given over here only, right? Now passing an entire array to a functions, that is we can pass the entire array to a function, not the arguments, but we pass entire array. This says in the previous section we saw two programs on which one in which we pass the individual elements, another in which we pass the address of the individual elements. So in the last example we have discussed, or we have shown, the call by value as well as the call by reference in case of the array elements. But now there is a time that how we can pass, or how we can use the entire array to a function, that is how to pass an entire array to a function rather than its individual elements. This is the demonstration of passing an entire array to a function. First of all the main will be used, then int num, that is num is the array variable that stores the data of this one. So these are the 6 elements that is used. Then display num0, that is first of all it stores at the num0 and then 6. Then display int pointer j int n, that is the first of all pointer j will be used and then n will be used. This is the function that is used. Then uses the for loop. First of all the element number will be printed, that is at the address, and then j plus plus. So in simple terms this is the entire array will be passed, or passing an entire array to a function. The entire array means all the 6 elements will be passed starting with the num 0. So starting at the location number 0 it passes all the 6 elements. So this is the definition. This is the passing the array, that is the actual argument. This is int pointer j int n. This is int I, that is in definition it will be used. Then starting with the 0 ending with the n minus 1 I plus plus, that is increment or the element equals to percentage d, then j plus plus. This says here the display function is used to print out the array element, that is the display function that is used to print the array elements. Now note that the address of the 0th location or element is being passed to the display function. The for loop is same as the one that is used in the earlier program to access the array elements using pointers. Therefore just passing the address of the 0th element of the address to a function is as good as passing the entire array to a function. It is also necessary to pass the total number of elements in the array. So it is necessary to pass the entire elements, because we pass the entire array as an element or as an array. So uses the display function would not when to terminate the for loop. Note that the address of 0 location can be passed by just passing the name of the array. Therefore the following two functions are same. So this is the same function if I use num0, that is ampersand num06, or either use num6. Both are the same concept. Now the real thing. If you have grasped the concept of storage of array element in memory and the arithmetic of pointer, here is some real food for thought. Once again consider the following array. So same array, the same output, the same input, the same memory address will be used. This is how we can declare the above array in C. This is int num 24, 34, 12, 44, 56, 17. So all the 6 elements will be stored in the array by using the array name as a num. We also know that on mentioning the name of the array, we get its base address. That is, this is the base address. That is, the base address means at the 0 location it will be stored 1, it will be stored 2, 3, 4, 5. Therefore, by saying pointer num, we would be able to refer to the 0th element of the array, that is 24. One can easily see that the num and the num plus 0 both refers to the 24. So either we use the pointer num or either we use the num plus 0, because we are using the num, that is, we do not specify any subscript. This is by default at locating at the or refers to the 0th location, that is 24. Similarly, if we say num plus 1 or the num I, that is the pointer num plus 1, we can refer the first element of the array, that is 34. In fact, what is the C compiler does internally? When we say num I, the C compiler internally convert into the num plus I, that is the num plus I, the same meaning of this one. So these are the notation that is used, that is either we use num I, num plus I plus num or I num, both are the same concept. This is the example how to prove it. We can use the 6 elements, one I will be used, then uses the for loop, then address will be printed, then this multiplied by this one I num. The output is this one. Next is two-dimensional array. Till now we have covered about the single dimensional array, that is the one element, one row will be printed, next row will be printed, one column will be printed, next column will be printed. Now there is a concept that is a two-dimensional array in which there are 2 rows, 2 columns, or 3 rows, 3 columns. That is, more than one row or more than one element will be printed in the array. That is known as the two-dimensional array. But there is no time left for the today's class, so let's stop over here only, and in the tomorrow's class we will discuss the two-dimensional array. So let's stop over here only, but if you have any doubts of the today's class, so please feel free to ask from me. One doubt came from the Larry, but Larry is not present over here, so the Larry doubt will be this is the Larry doubt. So this Larry doubt will be carry forward to the next day or the tomorrow's class. That is, I will take this doubt in the tomorrow's class, that is after the class. This is the doubt that is given at the 3:55 p.m. like this one, but I thought that why I waste the time in clearing the doubts there. If I took the 10 minutes before the class, that if I kept the 2 or 10 minutes before ending the class, so why don't? But Larry is not available over here only, so let's stop over here only, no issues. I will take this doubt in the tomorrow's class. So that's all for today's session. In the tomorrow's class I will be taking your next topic, that is two-dimensional array. Thanks a lot everyone. Thank you so much. Goodbye. Bye bye.